Today's lesson is on the Pythagorean theorem. It is most likely probably one of the most famous mathematical relationships that you will study in high school. All right, so with this picture, it's pretty easy to see the vertical and horizontal distances between A and B. And so what we mean by that is vertically, how much is changing? Well, it's just 3. Horizontally, how much is changing? Well, it's 4, because we can just count the squares. But from A to B, we can't actually find that distance diagonally, all right? It's not perfect, just 1 each square. So we need to find a way to find that exact distance, and that's how the Pythagorean theorem was discovered. All right, so this only works in right triangles, and a right triangle has a right angle, so 90 degrees. All right, the two sides that form that 90-degree angle are the legs. Those should be the two smaller sides. The hypotenuse is always the side across from the right angle and is also the longest side, and this we usually call with side C. So A and B are the legs, C is the hypotenuse. So what this theorem states is that if we take A squared plus B squared, it equals C squared. So if you square each leg, add them together, that's the same length as your hypotenuse squared. All right, so that's true for every right triangle. So to start, all we're going to do is label hypotenuse versus leg. All right, so to start, the legs connect and form the right angle. So I know that's a leg and that's a leg, which means the longest side and the side across from the right angle is the hypotenuse. All right, so try the other two and then check back in. All right, here's what I got. Hopefully you got something similar. And once you're ready, on the back side, we'll start finding some actual distances. All right, let's start with the first one. So from A to B, we cannot calculate that distance, but what I can do is make a right triangle. So pretend that's a perfectly straight line. We have one leg length of 3, one leg length of 4, and we need to find the hypotenuse. So if we take 3 squared plus 4 squared should equal, I suppose I should label this C, not X. So that should equal C squared. So if I do 3 squared, that's 9, plus 4 squared is 16 to equal C squared. So we get 25 equals C squared. Now we found C squared, but I want just regular C. So how do I get rid of that square? Well, I take the square root. So C equals positive or negative 5. Remember, anytime you put the square root symbol in or the radical symbol, you need the plus minus. But let's think about it for a second. Can our distance really be negative 5? All right, distance really can't be negative. You wouldn't go out and say, hey, I'm going to go out and run negative 2 miles. You're still running 2 positive miles. Maybe it's just in a different direction. So really, for this one, we would say C equals 5 only. We would forget about the negative 5. All right, so it's all about the context of the problem. So on to the next one. I can make one leg with a length of 6. My other leg also has a length of 6. And then I have my C as my hypotenuse. So I get 6 squared plus 6 squared, that's my leg and my leg, equals C squared. So 36 plus 36 equals C squared. And if we add the 36's together, we get 72 equals C squared. Now again, in order to get rid of that square, because I want plain old C, I'll take the square root, so it cancels. And we get C equals approximately 8.5. All right, third one like this, and then we switch things up a little bit. I have one of my legs has a length of 2. My other leg has a length of 6. There's my right angle, which means that's my hypotenuse. So if I use the Pythagorean theorem, 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared. So I get 40 equals c squared. So since I want regular c, not c squared, I will take the square root of each side, and I get that c equals approximately 6.3. All right, so there are the answers for the first 3. All right, now we move on. And first thing, I want to label my sides A, B, and C, or at least my hypotenuse. So I know that I know my hypotenuse, and I'm missing one of my legs. So in this top one, my legs are x and 7. My hypotenuse is 11. So I could have x squared plus 7x, that's a squared plus b squared, equals c squared. So same formula, it just looks different. So x squared plus 49 equals 121. So now, if I subtract 49 from both sides, I get x squared equals 72. And I know that when I take the square root of 72, I get around 8.5 for that missing side length. And our last one, again, we're missing a leg. So this one I could have 12 squared plus x squared equals 20 squared. So 144 plus x squared equals 400. All right, now I want to solve for x, so I'll subtract 144. So I can start to get that x all by itself. So I get that x squared equals 256. And to get plain old x by itself, I will take the square root. And I get that c actually works out to a nice even 16 on this one. All right, so be careful on which side of your triangles you know. Make sure you know the difference between the legs versus the hypotenuse. And then we should be good to go.